This app.py file contains code for a Flask web application designed for processing and visualizing EEG, electroencephalogram, data. The application includes functionalities for filtering, denoising, and analyzing EEG signals. Here's a brief overview of its key components. Imports and setup. The script imports necessary libraries, Flask, NumPy, SciPy, Pandas, PyWavelets, and scikit-learn, and sets up the Flask application. Data loading. It loads EEG data from a text file, with parameters to control the start time, duration, and frequency sampling, FS. Signal processing functions. Butter_bandpass and butter_bandpass_filter. Implement a bandpass filter using a butterwidth filter. Wavelet denoise. Denoises the signal using wavelet transform if enabled. Flask routes. Serves the main page of the application. Get_data. Handles requests to process and return EEG data. It allows for extracting segments of the EEG signal based on start time and window size, applying filters, and generating power spectral density, PSD, plots for different frequency bands, delta, theta, alpha, beta. It also supports wavelet-based denoising and provides metrics like signal-to-noise ratio, SNR, and mean squared error, MSE. Main execution. The script runs the Flask application in debug mode when executed directly. The application seems focused on providing a user-friendly interface for EEG data analysis, suitable for research or educational purposes in neurosciences or biomedical engineering. This index HTML file is the main page for a web application that visualizes EEG, electroencephalogram, data. The structure and content of the page suggest a user-friendly and interactive platform with various features for EEG data analysis and conversion to music. Here's a breakdown of the key elements. Head section, meta tags, set properties for social media sharing and SEO. Title, EEG data visualization. Starsheets, includes links to starsheets for page styling. JavaScript libraries, a reference to the Plotly library for creating interactive graphs. Body section. Header, contains a navigation bar with links to home, about, and contact pages, and a logo for the project name, Barnachaos. Main content. Controls panel. Users can interact with various controls to manipulate EEG data visualization, wavelet denoising options. Selection of wavelet types and levels. Detrend toggle. Whole spectrum display option. Frequency scale and filter order selectors. Channel selection and window size adjustment for data viewing. Visualization area, divided into sections for displaying the raw EEG signal and its frequency spectrum. Output section, displays the signal-to-noise ratio, SNR, and mean square error, MSE, of the processed EEG data. EEG to music converter section. Describes the features and functionalities of the EEG to music converter, including file scrolling, channel selection, window size selection, and various toggle options for detailed analysis. Provides insights into the output visualizations like the raw signal chart and spectrum chart. Includes technical details and data source information, acknowledging the use of publicly available NeuroVista intracranial EEG data. Scripts. This JavaScript file is for a web application that visualizes and converts EEG data into sound. It's structured to respond to user interactions and fetch data accordingly. Here's a breakdown of its key functionalities. Initialization. The script waits for the DOM to be fully loaded before executing. It initializes various UI elements like sliders, toggles, and selectors. Configuration. It sets up the API endpoint and checks whether the app is running in a production environment. Event listeners. Various elements like the file scroller, channel selector, window size input, and others have event listeners attached to them. These listeners trigger the fetch data and render function, which fetches new data based on the current UI settings and updates the visualizations. Data fetching and rendering. Fetch data and render function makes an API call with the current settings and processes the returned data. It updates two Plotly graphs, one for the raw EEG signal and another for the frequency spectrum. Signal-to-noise ratio, SNR, and mean square error, MSE, values are updated. Audio context initialization. For the EEG to music conversion feature, an audio context is used to play sound. EEG data to music conversion. Play sound based on EEG data, converts the current EEG data to sound. Map EEG data to notes, maps EEG data to musical notes based on the power in different EEG bands, delta, theta, alpha, beta. Play frequency, plays a frequency as sound using the Web Audio API. Utility functions. Functions like normalize power, get node range, map power to note, and node to frequency are used to aid in converting EEG data to music. In summary, this script enables a dynamic, interactive web application where users can visualize EEG data, adjust parameters like channel, window size, filters, and convert the EEG data into music based on various parameters. The application appears to be well suited for educational, research, or exploratory purposes in fields like neuroscience and bioengineering.
You list all the magic numbers in all the pieces of code provided above. Yep.
Certainly. Magic numbers are numerical values with unexplained meaning directly used in source code. They can make the code less readable and more difficult to maintain. Here's a list of magic numbers found in the provided code snippets. 400 in FS equals 400. 31,610 in start underscore time underscore in underscore seconds equals 31,610. 100 in duration underscore to underscore load underscore in underscore seconds equals 100. 10 in duration underscore to underscore display underscore initially underscore in underscore seconds equals 10. 0.5 in NYQ equals 0.5 asterisk FS. 2 in multiplier equals 2. 50 in band underscore ranges and filtered underscore data, the upper frequency limit for each band. 0 to 10 in less than input type equals range, id equals levels, name equals levels, min equals 0, max equals 10, value equals 5, greater than. 1 to 100 in less than input type equals range, id equals window size input, min equals 1, max equals 100, step equals 1, value equals 10, greater than. 0.03 and 2 in play frequency, volume equals 0.03, duration equals 2. 0.
Okay, so we have those in Python script. Magic numbers, actually not magic numbers. So leave those alone. In index.html we have levels going up to 10. We actually want to test this going up to double that, see what difference to the noise reduction it does, it makes. Now in JavaScript, yeah, those ones, the volume and duration, we want to either control automatically or have controller sliders on the front page.
.03 and 2 in play frequency, volume equals 0.03, duration equals 2. 0, 10, 50 in fetch data and render, specifically in the loop filtering the spectrum data. 12 in note to frequency, as part of the formula to calculate frequency from a musical note. 49 in note to frequency, as part of the formula to calculate frequency from a musical note. 440 in note to frequency, the frequency of the note A4, the standard reference pitch. 10,000 in a script tag for Google AdSense, as a delay time for script loading. It's good practice to replace these magic numbers with name constants, which makes the code more readable and maintainable. For example, fs equals 400 could be replaced with a descriptive name like sampling underscore frequency equals 400.
We can leave it fs, that's for sampling frequency, that should be fine. And we have this focusing on volume and duration. Wait a second, just remembered that we might have already done. So we want to control volume, we want to link volume to the whole spectrum, the energy of the whole spectrum. I'm pretty sure we did it yesterday, or did we just ask GPT to do it but didn't actually implement it? I have to check the code quickly. Yeah, the volume. Yeah, it's set to default. Yeah, so we didn't implement that code from yesterday. I have to do it now. So essentially the idea is to control the volume by the whole spectrum, even though it might be problematic as sorry for that. So we have this seizure in this recording, so it might be just very soft before and after the seizure. I think channel 14. Yeah, so if we map amplitude to the power in the whole spectrum, it would just become very loud during seizure over there. So before seizure we have the power going up to 500, and during seizure it's going up to 8000. Just the effect of the different window size. Yeah, this power number should really be, we do normalize it somewhere from 0 to 1. That's not what displayed on screen. So yeah, if you have any ideas of how to map, how to control the volume at the moment is always the same. We can try it quickly. The other thing is we want to the other option is to just give the user control of volume and duration. Okay, so focusing on volume and duration, we would like to have two options. Either the user select the actual value of each using an input on the front panel, we also want an option to automate volume and duration. For example, we might link volume to the power in the whole spectrum of the EEG, and duration could be linked to the window size. Yep. Just read out loud what it says.
To implement the features you've described, you would need to modify both the front-end, HTML, and the JavaScript code of your application. Here's a breakdown of how you can achieve this. User input for volume and duration. Add input elements to allow users to manually set the volume and duration for the audio playback. Example HTML elements. HTML copy code less than label for equals, volume input, greater than volume, less than, label greater than. Less than input type equals, range, id equals, volume input, min equals, 0, max equals, 1, step equals, 0.01 inches value equals, 0.03, greater than. Less than label for equals, duration input, greater than duration, seconds, less than, label greater than. Less than input type equals, range, id equals, duration input, min equals, 1, max equals, 10, step equals, 1, value equals, 2, greater than. Add toggle switches to enable or disable the automated setting of volume and duration. Example HTML elements. HTML copy code less than label class equals, switch, greater than. Less than input type equals, checkbox, id equals, auto volume toggle, greater than. Less than span class equals, slide around, greater than less than, span greater than. Less than, label greater than. Less than label for equals, auto volume toggle, greater than auto volume less than, label greater than. Less Get the values from the input elements for volume and duration. If auto volume is enabled, calculate the volume based on the power in the whole spectrum of the EEG. If auto duration is enabled, link the duration to the window size selected by the user. Before playing the sound, check if the auto volume or auto duration is enabled and use the respective values. Example. This approach allows users to manually set volume and duration or opt for automated settings based on EEG data characteristics, offering a more dynamic and interactive experience.
Yeah, this code, obviously, it's not enough. It's not going to do the whole thing. On the front page, so all those are available in another application. So put them down the bottom. So everything from a window denoise, calling it music and not sound because we actually using musical notes, musical notation. Let's turn oops, turn whole spectrum back on by default. Control I. Turn on by default. Should be a simple task for a GitHub Copilot. Everything past the wavelet denoise. Yeah, we'll split the controls into two sections. It's like it's already split. Place wavelet noise below the bottom chart. Same as with the whole spectrum. Right, so we have changed the label, EEG to music, channel number, select channel number, window size makes a big difference, and the file scroller, it's the main controller. Where's the scroll? Right, under this scroll we want another control. Right, we have volume and duration and some default values. We added these two switches as well. See what they look like. Right, so we have the volume. Doesn't really fit the screen. Anyway, it should look like this. Should we turn it on by default? Well, now let's try the manual volume control first. So currently it's all the same volume. Okay, get values from the HTML into the JavaScript code. Somewhere here. Be a good place for it. And calculate. So we need another function. So the volume should be linked to the whole spectrum. Okay, so we need those two functions. Yeah, the EEG power in the whole spectrum should be It's this value here. Close this for a sec. So that's the whole EEG you want to link. So the idea is when you can set the volume manually. Maybe if you do, this should, if you touch this scroller, the toggle button should turn off. We don't have it yet, but that could be a better way of implementing it. When you turn it on, it should take energy, the overall energy for the whole spectrum. Yeah, I see there will be a problem with this, but give it a go. If you don't like it, you could just set your own volume manually. For duration, we're linking the duration of each note being played to either manually, you could set it manually, or if it's turn auto duration, will be linking the duration of each note being played to the window size, which you can change yourself. Bottom line, we need both of these functions. Check them down. The bottom or top? Yeah, this JavaScript code becomes ridiculously long. I'll check them up the top. So we can place them here somewhere. And then in play sound, do we have play sound? Pretty sure we have a play frequency or something. Have play sound on. Don't have a function called play sound. We have play frequency. Play sound based on EEG data is using play frequency. That's right. Is this just for testing? Just as an example, is it? Yeah, play sound. Is not what we need, but it's just an example. Okay, instead of an additional function play sound, can we just modify the play frequency function that takes frequency, volume, and duration as inputs? Yep. Play frequency. Oh. Right, so now we're taking more inputs, auto volume, auto duration. Okay, do we need all that? I don't think so. High frequency. Definitely don't need the EEG data because we already have the frequency. Why do we need the EEG data? That's odd. Okay, what are the two new functions called? So we definitely need this to calculate auto volume. Okay, let's try ChatGPT. Clear this chat. Okay, these two functions calculate auto volume and calculate auto duration. One the play frequency function that takes volume duration. Yeah, this one here. Is play frequency. Should play frequency use this to just happen? Oh, come on, that's not fun. Oh no, and it's no, because it's not having the whole context. You have to actually, I don't know how the GitHub Copilot works, but you need to actually select the whole code and ask this question again. Yeah, so now looking at the 200 lines of code, you can't make decision. However, I can tell you that if play frequency has to adjust the volume and duration based on certain conditions, it should make sense to use calculator yes function if these adjustments are not necessary for play frequency. Well, so currently we have play sound. So this code I suspect GitHub Copilot won't be able to do it. And what was the problem with GPT? I haven't actually read this.
Certainly, you can modify the existing play frequency function to dynamically handle the volume and duration based on user input or automated settings. Here's how you can adjust the function. Add parameters for volume and duration. Modify the play frequency function to take volume and duration as parameters. Determine volume and duration inside the function. Inside play frequency, check if the automated settings are enabled and calculate the volume and duration accordingly. If the automated settings are not enabled, use the values from the user input. Integrate the automated calculations. Include the logic for calculating automated volume and duration within the play frequency function. Here's an example of how you could modify the play frequency function. JavaScript. Copy code function play frequency, auto volume, auto duration.
Okay. A question though. Why do we need to input the EEG data? So we can actually calculate volume. Okay, maybe the original idea wasn't too bad. I have this play sound.
This approach allows users to manually set volume and duration or opt for automated settings based on EEG data characteristics, offering a more dynamic and interactive experience.
Okay, problem now is that play sound is not being actually called. So those are default values, but play sound so does it mean that everywhere we use play frequency we now should be using play sound? Play sound is currently not being used. Made suggested changes.
If the play sound function you've implemented is not being used, it needs to be integrated into the event flow of your application. The function should be called at appropriate points where sound playback is required. Here are some steps to integrate play sound into your application. Identify trigger points for sound playback. Determine when you want the sound to be played. For instance, after fetching new EEG data, when the user changes the channel or adjusts the window size. Common trigger points might be inside event listeners for UI elements like sliders, buttons, or after successfully fetching and processing new EEG data. Modify existing event listeners or functions. Update your existing event listeners or functions to call play sound at the appropriate times. For example, if you want the sound to play after fetching new data, call play sound at the end of the fetch data and render function. Adjust play sound to use current EEG data. Ensure play sound uses the latest EEG data available in your application. This might involve passing the current EEG data as a parameter to the function or accessing a globally stored variable.
Yes, I assume instead of play frequency, it should be play sound. And this is not taking any parameters, is it? Oh, it's not taking any parameters, it's just essentially calling play frequency and yeah, either taking the manual volume or taking the automated volume, which then be taken from the whole spectrum energy in that particular window. And that's normalized. Okay. So I assume instead of play frequency, we just do play sound with no inputs. We only have two places where we play sound. What was working before, so just restart the page. Doesn't work anymore. Frequency is not defined. Should take frequency as input. Must be the order. Let's try GitHub pilot for this. Could be the order. Do we have to do it? Making frequency global variable. Should be a global variable. Yeah, we need the frequency as an input. more sense. Okay, sorry for that. Okay, volume does work. It's the volume. Okay, the auto volume does not work. Right, actually, auto duration does work. So if, yeah, probably should make it so when you use this scroller. Let's restart it quickly. That's manual by default. Right, so this duration does work manually. It's still playing the previous one. It's actually this problem. I'm pretty sure I told it not to play when another note is playing. Stop playing the previous one. It's obviously not doing it because when we increase this duration, so now it's playing short notes, which is fine. Put it roughly in the middle. Yeah, it starts playing them on top of one another. Right. So I can play a long one. It's still playing the previous one. When we do this auto duration, it should be, no, actually it should be grayed out, and this value should indicate what's currently being used, and it should essentially be linked to that number. Actually works pretty well, surprisingly. Okay, it's pretty annoying. It can be quite annoying, but I might let you play with it, but the auto volume does not work. Anyway, when auto duration is selected, something should happen to this one. Should be grayed out and showing what's the current value is. Okay, it's working well. It is working well. However, we wanna make a few more adjustments. For example, when auto duration is on, the duration seconds scroller should be grayed out and ideally indicating the current value. Yep. I mean, this should be the case for auto volume as well. That doesn't work at the moment.
To implement the feature where the duration slider is disabled, grayed out, and shows the current value when the auto duration toggle is on, you need to make some adjustments to both your HTML and JavaScript code. Here's a step-by-step guide. HTML. Ensure that your duration input and the auto duration toggle have proper IDs set, which will be used in the JavaScript. HTML. Copy code less than input type equals, range, id equals, duration input, min equals, 1, max equals, 10, step equals, 1, value equals, 2, greater than. Less than label class equals, switch, greater than less than input type equals, checkbox, id equals, auto duration toggle, greater than less than span class equals, slide around, greater than less than, span greater than less than, label greater than less than label for equals, auto duration toggle, greater than auto duration less than, label greater. JavaScript. You need to add logic to handle the enabling and disabling of the duration slider, as well as updating its value based on the auto duration calculation. Add event listener for auto duration toggle. Add an event listener to the auto duration toggle checkbox. When toggled, it should enable or disable the duration slider and update its value if necessary. JavaScript. Copy code const auto duration toggle equals document. Get element by id, auto duration toggle, const duration input equals document. Get element by id, duration input. Auto duration toggle. Add event listener, change, function, if.
So related to the auto duration toggle. See if it works at all. Yeah, it's getting grayed out as requested. But it's not the expect this grayed out value still change when I change the window size.
This function should return the value for the duration based on your logic linking it to the window size or other parameters.
Yes, we already have that. Does it need the window size input? To try this.
Ensure the correct state of the duration input when the page loads, depending on whether the auto duration toggle is checked or not.
Right, so this is happening when we start app. Expect that to change. Oh, it is changing, but only after. Yeah, that's a bug there. And yeah, volume is the tricky business. Yeah, the auto volume. It doesn't work. Oh, it's okay now. I don't know why I need to do that. Oh, wait a second. If it's checked, so if it's turned on, duration disabled, true, duration input value. No, I do need to do that, but where do I do that? No, something's wrong. Something is wrong. Why do I need to do this again? Yeah, it's a bit weird. Yeah, I don't see why I need this again, because we're already doing this in the event listener, but that's not right. So event listener is only doing it when the change occurs. If it's checked, if it's turned on. No, it can't make sense. It's not working. So this value should be recalculated and updated. disable it after it's being updated. Try. Anyway, that's the duration. And if it's automated, it's linked to the window size. There's a little bug there, but that should be okay. Now with the volume, I have volume 0. It's volume 1. And obviously it will become super loud if I keep going. So first need to check. A volume input. I don't know why is it? It's from 0 to 1 and steps of 0.01. So when I load the page, apply the same sound. Right, so this volume is going from 0 to 1 in these tiny steps, which is a bit odd. If anything, it should be 0.1 or something. A couple of issues with the volume. First, it seems like it's getting way too loud. Should the maximum volume be reduced tenfold or something? The second problem is that auto volume doesn't work. It gives the following error. Let's actually check what the error is. Volume. Some reference is not defined. What? Anyway, it gives this following error.
If the volume is getting too loud, reducing the maximum volume is a sensible approach. You can do this by adjusting the range of the volume input and the logic that calculates the auto volume.
So the volume seems to be okay. Don't want to play it too loud at the moment. Calculating the auto volume. Okay. How do I do that? calculate total volume. Will be within the new range. I assume so. Just kind of hoping for it to appear on the site today, but we decided to make all these adjustments. I'll still try publish it today.
The error indicates that some reference power is not defined in your calculate auto volume function. You need to define what some reference power represents in your context and provide a value for it.
Do I have some reference power? Some reference power. Okay, no, this meant to be some reference power. No. The EEG data should have the power of the whole spectrum. This is what being displayed over here, whole spectrum. Whole spectrum toggle. Fetch data and render function. It's a long function. How do I fetch the whole spectrum?
Make sure to use this reference power value correctly in your volume calculation logic.
Okay, at least now we know what the problem is. That the average power is not an average power. It should be in the data. The sum reference power should be the value of the whole spectrum power that should be available in the EEG data. Yep. Is that what it's called? Spectrums? I don't think so. Is it EEG data spectrums? Wait, it is using it already. What's it calling it? Some data spectrum. Calculate out the volume. Yeah, okay. That makes sense. Why are we calculating it though? Well, right, because we have the multiple data values. So yes, we're calculating the average for it. Yeah, we have the total power. Why is it called some reference power? No, average power makes more sense. Wait a sec. Power, total power. Okay, let's read this.
To set some reference power as the value of the whole spectrum power from your EEG data, you will need to calculate this value from the EEG spectrum data available in your JavaScript code. Let's revise the calculate auto volume function to do this. Calculating whole spectrum power. Modify the calculate auto volume function to calculate the total power of the whole spectrum from the EEG data. This is typically done by summing up the power values across all frequencies in a spectrum. Updating the function. Adjust the function to calculate the sum reference power as the total power of the whole spectrum, and then
Okay, where it's going wrong is the fact that these spectrums should already contain everything we need. The auto duration works okay, but volume doesn't. Hey, can we log? What's going on? I assume we'll be getting this error. No, we're not getting that error. Let's clear this for a sec. Yeah, the sum reference power is not defined. Assuming EEG data spectrum does exist, let's do the whole EEG data in the log. This EEG data and zero signals SNR spectrums. On spectrums, right? So in spectrums, we already have whole spectrum. So we cheat that as spectrums as whole spectrum. That's the one. Use whole spectrum to calculate the volume.
Given the structure of EEG data, spectrums in the presence of a whole spectrum entry, you can calculate the volume based on the power in this whole spectrum. Here's how you can modify the calculate auto volume function to utilize the power data from the whole spectrum. Locate the whole spectrum data. Find the spectrum object named whole spectrum within the EEG data spectrums array. Calculate the total power of the whole spectrum. Sum up the power values, the Y array, from the whole spectrum to calculate its total power. Updated calculate auto volume function. JavaScript, copy code function calculate auto volume, EEG data, const whole spectrum equals EEG data, spectrums, Find spectrum equals greater than spectrum.name equals whole spectrum, if whole spectrum. Return 0, default volume when no whole spectrum data is available. Calculate the total power of the whole spectrum const total power equals whole spectrum. Y. Reduce sum value equals greater than sum plus value 0. Assuming average power is calculated based on the current EEG band of interest const average power equals asterisk your logic to calculate the average power of the current band asterisk. Normalize the volume based on the whole spectrum power. Note, adjust some reference power based on your data scale and desired volume range const some reference power equals 50. This is an example value. Adjust as needed.
Adjust as needed is a great advice.
The choice of some reference power is crucial. It should be set to a value that makes sense for your application and data scale. This value serves as a normalization factor and should be determined based on the typical range of values in your EEG data. Ensure the volume calculation results in a value within a safe and acceptable range for audio playback.
Is it finding the spectrum name? Why do I need to search for it? It should be there. Do this.
The average power in the context of your EEG data visualization and auditory representation tool seems to be a metric you want to calculate for a specific EEG band or for the EEG data currently being analyzed. This value can be used to determine the volume for audio playback in relation to the whole spectrum power. Here's how you might calculate it. Choose the EEG band or data for average power calculation. Decide which part of the EEG data you want to use for the average power calculation. It could be one of the specific bands, like alpha, beta, etc., or some other relevant portion of the EEG data. Calculate average power. Sum up the power values in a selected band or data portion and divide by the number of data points to get the average power. Implementing in Calculate Auto Volume.
I have no idea why it's getting confused so much. Yeah, I don't get this average power calculated based on the current EEG. Don't get it. And over here, the total power is not being used.
In the provided calculate auto volume function, total power was calculated but not directly used in the subsequent normalization of volume. Instead, average power was being compared with some reference power for the volume calculation. The total power variable can be used as a reference power or in any other suitable way depending on the specific requirements of your application. If you intend to use total power as the reference for normalizing the volume, you can modify the function as follows. Using total power as the reference for volume normalization. In this approach, total power of the whole spectrum is used as a reference to normalize the average power of the selected EEG band. Modified calculate auto volume function.
Okay, this one makes slightly more sense.
By using total power as a reference, you're essentially setting the volume relative to the overall power of the EEG spectrum. This can provide an intuitive way to represent the intensity of specific EEG bands in relation to the entire spectrum.
Return the volume. And lock the volume to console. So that's the default volume. Doing auto volume. Yeah, that's interesting. I don't know if you can hear anything, probably not. The volume is too low. Seems to work. It's working in a sense that's much lower when there's no seizure. Is it? No. So taking alpha.
Normalize the volume using total power of the whole spectrum as reference.
Yeah, the problem is it have some max power. It's 100. Seemed to work okay. Yeah, I don't like this magic number. But it works. Should try this one. Yeah, for calculating auto volume. Total power is not actually being used. We want to use total power instead of average power. Can comment this out. Oops. Sorry for that. That's obviously saturated. Using total power. Okay, now I think its volume of 1 is obviously too large. Let's make this a large number like 1000. Okay, that's still too large. Right, so this volume, this magic number, volume is better. Yeah, the seizure is much louder on this channel. Yeah. So you will have loudness cues for this. Check S is okay. Or not. So you can decide if you're doing auto volume or not. And we will continue.